Yeah, hello. Thank you for your patience, and thank you for having us here. So for us, it's basically the first time to get involved to the AutoSAR group. So for us, it's very interesting to be here, to talk to people, and to get to know the community. So thank you for that, for having us here. My name is Michael Spitzer. I am responsible at our company for the platform technologies. And this is Laura Gregorc. She is responsible for the Edge AI parts. Yeah. So, yeah. Oh, okay, thank you. Yeah. At first, I would like to give a short insights what we are talking about today. At first I would give a short introduction about our company. Then I will talk about our research and development demonstrators at our company. Then I will show you a logical integration of in-vehicle data and instrument cluster. And we implemented for that an own framework. Then I will hand over to Laura, and Laura will speak about the role of Edge AI, the Edge AI in the middleware, the Edge AI in AutoSAR, and the Edge AI in infotainment space. A big topic here is the orchestration of the chip. And then we have brought a data-driven use case to show you more insights about that. And last but not least, a conclusion about all this. Yeah, but at first, a few words about our company. We are a research company based in Graz, Austria. We are about 250 people, and we are partly owned by the industry and partly owned by the academics. So we are the classical man in the middle, I would say. So we're doing mostly applied research together with partners, and we are a non-profit organization. So usually we are not building products, so we are building prototypes together with partners, and then we're handing over the knowledge and the insights to the partner, and the partner is then building a product out of it. So yeah, our main domain is of course automotive, but we have also other topics in our research company. We have the big rail department, and we have small activities in health, in energy, maritime, and also in defense. Our partner network is quite big right now. We are working with a lot of OEMs in Europe, but not only in Europe. Then we are working together with tiers. For example, from the OEM side, BMW, Audi, Volkswagen. From the tiers, we are working with Bosch, with AVL, and other big companies in this field. And in research, we are mostly working, of course, with university. We are working with Fraunhofer, with Stanford, with MIT. And yeah, and our rail department is mostly working in Europe. And we have additional some projects running in the health sector with Siemens Healthineers. Yeah, but now I would like to introduce you to our research demonstrator. So usually we have some projects with the OEM together, but also some activities without the OEM. So sometimes we are buying cars from the market, and we're building new technologies in these already running cars, and to investigate new possibilities, what to do in the cabin, for example, how to build new applications for the driver. And we are also doing studies with these cars then to get feedback of the drivers. I would like to introduce you to our Evodis demonstrator. This is the base is an ID4. It's the ID4 is already a few years old. We got access to the full in-vehicle networks. We built our own AOSP-based Android Automotive bare metal on an infotainment SoC. And we attached all the networks to it. We integrated the displays, as you can see here. So we have our own AOSP running and our own apps on top of that. Yeah. Additionally, we integrated health data from, for example, the Apple Watch Ultra to get more insights of the driver's health state, and to use this data and to get more insights about the status of the driver, and that the car can react if the driver has a health problem. Yeah, the integration with the in-vehicle networks we did in Rust, complete from scratch, and we connected it via IEEE 1722 to the in-vehicle networks. So for us, the programming language Rust is everything we are building is we are built in Rust from scratch. Yeah. So for us, the in-cabin experience is very interesting. So we attached, for example, the LED strip of the ID4. We accessed the display, the console display, and we are already doing stuff with the instrument cluster as well. But we know instrument cluster is a very specific topic regarding safety and security. We attached a new automotive in-cabin camera, as you can see here on top. And we are doing a lot of projects regarding camera-based detection of in-cabin situations. We have our own SoCs placed in the car and attached to the networks. Yeah, so I would like to so the video is unfortunately not working, but I can tell you the story about that. This is a very simple demo. You can see the car, you can see our running application in AOSP. And when you turn the steering wheel to the left or to the right, the LED strip is the red bar is moving right or left. So it's a very simple demo that we have full access to the in-vehicle networks and that we can build apps upon this data, and we are able to read and write data in the car. To make this possible, we built our own framework. We called it Shift. It's software-defined hybrid integration framework for transportation. What does this framework do? The framework implements all the interfaces to the in-vehicle networks. We built our own OEM agnostic development. For us as a research company, it's important that we're not tied to specific OEM. So we want to be a generic interface. We want to do stuff with multi-brand solutions. We are investigating multi-brand software as well to see what we can do if we have, for example, a multi-brand fleet. Yeah, we did a lot of multi-brand prototyping. We're testing development this framework in Volkswagen cars, in Ford cars, in Mercedes cars, but several other cars as well. Yeah, and there came the point where we came in touch with, of course, AUTOSAR. A lot of standards we saw in this field are related to AUTOSAR, so that was our reason to come here and to connect to the community. So, for example, the IEEE 7022 standard is defined in your space. Then the diagnostic data forwarding via SOVD is, of course, also a topic. Diagnostic is in general a very interesting topic for us. So with diagnostic data, you can do a lot of interesting things. You can, for example, use LLMs to describe the problem more to the driver or more to the fleet manager. So diagnostic data is in general very interesting for us. So that was the reason why we upgraded the ID4 with our own SOVD server. Yeah, and of course the instrument cluster overlay support, then that you have security and safety regulations. So of course there's also the touch point to AUTOSAR. Yeah, so the Shift architecture. So the framework we have access to the displays, we have access to the cans, we have access to UDS. And we deployed two different SoCs. We have one which is acting as a middleware based on Linux, and we have one which is completely the EOS implementation from our side. Yeah, the displays are connected to our EOS SoC by an HMI controller. And in the middleware, there's a data gateway running where you can access the data of the car and also the diagnostic data. Yeah. So that's all about the platform. And now I would like to hand over to Laura, our AI expert.
Thank you, Michael. Hi, also from my side. I'm Laura. I'm a machine learning researcher at Virtual Vehicle. And given this platform Michael described, the Shift, I want to use that, and I try to bring the AI models into the car. So it's not for the sake of AI, but it's to make the functions more intelligent. And I'm sorry. Okay, so I think Edge AI is really important. And our goal is to have realistic platforms for future scenarios and future cars. So there is a huge topic about AI accelerators. And that's a real battle out there, actually. So it's all about who has the most tops with the least watts. And currently we are using a AI accelerator with 40 tops, so tera operations per second, which uses only 2.5 watts. And I think that's a good start. And the most important thing is also the costs there, so that it's not too expensive to have computational power in the car. And then there is, of course, the question, why don't use we cloud? And we think there are several advantages of Edge AI. So, of course, the first and the most important one is offline availability. So we are not dependent on the internet. And if some servers are down, that's fine for us because we definitely run everything locally. And we don't have to share data to any server. So that's specifically really important in Europe, but I think also in Asia, so that we have no external data sharing. And also, of course, no transfer costs we really rely on. So we can decide what data points are shared with the server. But there are also challenges with Edge AI. So the resources are limited, as I already said. So we have small AI accelerators or smaller GPUs in the cars. And of course, there is the strict execution time requirements and also the safety regulations too. So just to give you a small overview, the classification of our Edge AI use cases in the ISO 26262 is we are mostly focusing currently on the infotainment side. So we are using non-safety functions for our Edge AI use cases, and it's mostly aftermarket use cases. Because, of course, the OEM can access their own hardware, but it gets really interesting when the ecosystem is getting larger. So I think also the OEMs and the third-party apps can profit by cooperation. All right. So as a next point, I want to get into detail how we execute Edge AI models, or how are we even able to execute models in the car. So usual pipeline starts with a machine learning framework, for example, PyTorch or Keras, or a pre-trained model we already have. And then we fine tune, make this model work for our use cases. But there we are already starting with the Edge AI topics. So the next point is the quantization. So the basic quantization is the optimization of the model for an AI chip. That's specifically for an hardware mostly. And what it does is we turn the model from 22-bit floating points to integer 8 or 16. And that step needs to be done, and we don't want to lose our accuracy. So we take a small subset of data and approximate with them our weights. And then the model is also changing the format. So we have then a binary format for specifically our car. And this format is then, or this model is then executed in the accelerator runtime, mostly in C++ in the car. So that's quite, as you can see, the orange steps needs to be done to make it work in the car. So it's quite an additional effort for that. That's why also not every model will run in the car. All right, then, so as we already told you, it's the first time for us here. So we wanted to give you a small overview where we believe that our models would fit in AutoSAR. So I definitely think we would be in the adaptive AutoSAR platform, and we would use an adaptive application for our inference runtime. And of course, we need sensors for our data, for the input. So there we make use of these interfaces, these ARA interfaces. And then expose to the dashboards or to the other ECUs using IEEE 7024, for example. But it would be, for me, it would be really interesting to open the discussion, and if later someone else can give you some insights if there's another place for us in AutoSAR. Coming from this execution to the infotainment space. So in the middleware, we run the model directly from the OEM, but it gets really interesting as soon as the third-party apps also want to execute their own models. And that can be done using Android. So we currently run AOS on our vehicle. And there we need to get access from the app in Android to our hardware, to the AI accelerator. And that there is a big question mark how this should be done in future. And the goal is also, or the challenge is also, that there are multiple apps running independently of each other, and everyone wants to use the same hardware. It's basically the same as we have a camera and only one app can use the camera. But it's way more complex because the camera is bound to a foreground service, while hardware is for AI can also run in background. So that's the orchestration issue we have here with AI models. And therefore, here we have again our whole concept. So we don't stop with the runtime in C++. We also need to access it via the app. There are some interests in having an abstraction layer here, and we really research on that. So there was an Android and an API, so a neural network API, but that's now deprecated. So we are really curious if there are other researchers out there too. To demonstrate that issue with orchestration, I have a simple example with me. So let's imagine there is an app which does driver personalization. So we want to identify who is driving the car. We need a pipeline of two models, face detection and face recognition. So we have as an input, a camera picture, and as an output, we have a name, potentially a name or unknown. And these models need to be used using the hardware. It's in an app. That's fine for us. Then a second app is installed. It's driver state, attention and health. I have, for example, my Apple Watch with me, and I also want to know if the driver is looking on the road. Now the issue is that the device is already busy, but the second app would be way more important when we drive, because otherwise we don't know if the person is looking on the streets. So how we tackle that is using the existing vehicle data too. So if you have fully access to all of the vehicle signals, we can define a rule-based which state the vehicle and the driver is currently in. So let's imagine the vehicle is standing and the driver opens the door. So we know that and we want to recognize our driver. Then we know who is driving, like the name. Second, then later we don't need to always check if the driver is still there because the door is closed and we don't assume that the driver is jumping out of the car. So next up, we see that the ignition state is starting, and then we let the second app have the possibility to run their models on the AI model on the AI hardware. As an output, we have attention, yes or no, while driving. Next I brought with me a video, which is showcasing this. So on the right side from your perspective, we have the infotainment screen and a theme like all of my widgets I need for driving. This system is simulating a car, but we have also the specific use case already implemented in our cars. We have the LED strip from the car directly here and infotainment. And Michael is entering the vehicle and gets recognized. And then later he drives. So right now he's driving and is distracted or not. The LED strip is also an additional output for us. Later he's stopping the vehicle, exiting the vehicle, and our infotainment screen sees that there is no driver currently in the car. Next up, I am entering the car and I get recognized. All my widgets are personalized for myself, and also my health data is also synchronized with the car. Next up, I'm starting driving again, and we can see where I'm looking or if I'm distracted or not. All right, thank you for the video. This cooperation was with Bosch, with our partners, and it was giving us a lot of insights. Now the videos are working. Okay, I just want to simply conclude the Edge AI. So I think adaptive AI is a future topic for us in the Edge AI field. So the model orchestration is not done yet. There are still open questions and an interesting research topic. And I believe always that we should start with smaller models and tackle our specific problems and not make an all-purpose model for everything. And also the most important stuff is that we later need to share our hardware in the vehicles and the resources. And I believe that all of the ecosystem can benefit of that.
Yeah, and from my side, as we see now, a lot of different platforms are emerging through the market, a lot of different tools, a lot of different platforms, virtualizations. So for us, it's not the question where to do that. It's more the question, what is the interface contract? Which feature should I provide? Which regulation should I have to fulfill? Our goal is to build platform agnostic features, and just the last step is then to decide on in which part of the car system this function should run. Yeah, that's all from our side. Thank you for your attention and for your patience. Yeah.
So thank you very much. Any questions? Okay.
It's already late.
Yeah, also I'm interested on the Rust side. So you said
I think there is one.
there's somebody. Okay.
Sorry.
Hi, my name is Adrian Baruta from Toyota Motor Europe. One question regarding commercializing such a product. What is the impact you see from the EU AI Act right now?
That's a very good question. For us, especially in the EU, it's very important to run as much as possible in the car to protect the data of the people, and to just transfer the data which is really needed on the platform side, for example.
Yeah, if I can add, for example, for the face recognition, it's really important that we don't save or store any images from the people. So we only store the embeddings of the faces, and then we would be confirmed with that. So I think it's an interesting topic, and I really like that there's the AI Act. But of course, the vehicle signals are really crucial for these use cases.
Okay. Because the EU AI Act actually covers the process side, right? So you will have some type of management system of the AI-related artifacts. And how would you see the collaboration with your customer? Because it will be some kind of split responsibility in such a management system.
Yes, of course. I think, I mean, for current use cases, it's of course not the case to manage it. But I think as soon as there are more use cases out there and more people want to use it, so the ecosystem should push that we want to use the local execution. Also, this topic arises more, and I think then we can focus really on the management side too. That it's also performant, so the performance is not reduced by some management tool. We need additional.
And additional to go into detail of the question, as a research organization, we are often also trying to get over these boundaries, to develop new feature, and this is then usually the next step together with the partners to make it really compliant. And so we're basically we are out of the game, I would say, if the prototype status is reached, and then we are helping to transfer the knowledge to the OEMs. For example, the OEMs is then taking care of more this regulation topics and to be compliant. So that's good for us that we can be a little bit, I would say, front runner as a research organization. And then we are doing this together with the partners to be compliant.
More questions? Maybe then I can ask my Rust question. Because I'm in multiple conference programs, and we always edit now in the recent 2 or 3 years, we added a Rust section. But I wonder about, because academia, you're close to also the fresh talent. And so how is this now adopted when you get now like fresh grads, they all are fond of your Rust? Is this the big thing?
Yes, it is. And we already see that especially the juniors, the new people are coming, that the error rate is quite low compared to C or C++. So the compiler is really powerful. A lot of mistakes in coding are already prevented. So we see a big advantage to use Rust. And as I said, all code which was created for this integration of the cars are completely in Rust. also the part of the AOS system where we attach to, for example, with the vehicle hull, we used Rust for that. And we are, and as you said, the young people who are coming, they are really, they really love Rust, and yeah,
they're really enthusiastic about working on it. They don't want to use C++.
And C, yeah.
Another question.
Sorry, last question. So, in your example, which was really nice, you are showcasing mixed criticality functions. So the one with recognizing the driver with a safety critical system. However, are you considering actually developing different solutions for safety critical and non-safety critical? Because of course the impact on the effort and cost is completely different if it's a safety critical system or not.
Yes, definitely. So the safety critical, for example, ADAS would be run in a completely different hardware. So we really believe that every ECU has then maybe his own AI accelerator or his own computational power to access. So I would definitely, split that, as we can also already see also here that the OEM's doing that already. But still, I believe that that's also an interesting thing we always discuss. There are several use cases can be done in several points in the car. So a driver personalization can be done by the OEM, but also in a fleet management system, so from a third party. So it's not always clear where to run your use case. But with the third party, you're of course not safety critical. So yeah. The worst part would be that everyone does the same use case in different places at the same time. We hope that that does not happen in future.
So I want to continue on one more on the Rust side. So now we talked about academia. So then on your like industry related projects, how many are using Rust?
We still need to do to convince a lot of partners to try it or to use it. Usually, we are allowed to do that as a in prototyping state. So they're quite open and they really want to know how does it work, how good is it working, and of course they are using it. Yeah. And they're really interested in the safety part of Rust, of course. Yeah. And there I see a lot of advantages. Yeah.
Okay.
So the partners are of course looking into it. They are not as convinced as we are. Yeah, not yet, I would say. Yeah, but it's growing, and we saw this here as well at the conference that a lot of industry partners or industry companies are considering it and are moving code to Rust, and we support it.
Okay, so let's turn this around. We have all these people here in the room. So who is already using Rust in a production project? Raise your hand. Is anyone using Rust in a production project at the moment? There's no recording of this. I'm just trying to get a sense. Okay. Then maybe let's, next question is, who is planning to use Rust in a production project or considering? Is this on your roadmaps at the moment? So we have 1, 2, 3, 4. Okay. Is this is there at least some discussion also in China on Rust? I mean, in Europe, I'm as I said, I'm at the 2 biggest conferences. I'm in the program board, and Rust is like typically one track already. So same here. I see you nodding. So it's the same here. Rust is no, not yet. Okay. Oh wow. Okay, interesting. Or maybe another language. Is there any other language which we are missing? Because I think it's also important to us what we need to address. I mean, mostly C, C++. Is it mostly C and C++? Okay, I see some notes here. Okay, interesting.
So we have to convince still.
Yeah. I mean, it's I think should be no boundary with this language, or in the sense of that certain regions everybody can use it, or there's not.
Yeah, I would be interested what the challenges then are. Is it the integration with the current systems? Because we always want to tackle that because we are applied science, so it's not that we always start with the green fields.
Okay.
So yeah, we try to open the discussion here. Yeah, definitely.
Mm-hmm. Okay. Yeah. So then, thank you everybody, and we are now in the coffee break. See you back here. at 4:05.
Thank you.
Thank you.
Thanks.